Okay, so Unit 2, Lesson 2.7. Okay, quiet please. Okay, so far we've been doing derivatives of functions in the form of y equals. Okay, we took the derivative of that. That'd be a quotient rule example. Okay, so we've already done that. It's no big deal. But when we get functions that are in the terms that like x and y's are together, instead of solving for y and getting two functions for this example, we're going to learn today how you can take the derivative of something with two variables. That's called implicit differentiation. Okay, so we're going to be able to take the derivative without having to solve for y. Okay, but just so you guys know, this is the equation of a circle. So we're going to talk about, this is not really relevant to what we're doing exactly, but what you'd have to do is, if they said to find the tangent slope of -4 and 3, I have to figure out which part of the circle that's on, and then I'd have to use that to differentiate. That's just a lot of stuff to do. Okay, instead of doing that, I don't need to move anything. I can do this implicit differentiation, okay, with x and y's to get my answer of my derivative. Okay, so what is it? Simply I don't want to say shortcut, but it's another method of doing when you have two variables instead of solving for y. Okay, is there any questions? So we're still taking the derivative. We're still finding the tangent slope. We're just doing equations and things that aren't y by itself. Okay, fair enough? Okay, so here's the example. We're going to do the one they were just talking about. Now this is where, while we've been preaching the Lebanese notation. So let's go over that one more time. So what does this mean? Derivative with respect to x. Okay? And then conversely, this is derivative with respect to y. And then what's this? It's the derivative of the function. That's like our f prime, right? This is equivalent to y prime or f of x prime. We haven't really been solved, right. We take this when y is by itself, and that's a good point. I'll explain that. But we've been taking, everything we had has been in terms of x. Okay, so actually let's talk about that. That's a good point, Morgan. So if we go y equals, let's say x cubed, right? And we're taking the derivative of all of this. This is going to set things up for today, so this is actually a great question. If I take the derivative with respect to x, I have to do it to everything, correct? And this is what we've been doing. So what's the derivative of respect to x of x cubed? Okay, so doing this operation is making that a 3x squared. Okay, well, what's weird about this one? There's no x. I can't take derivative with respect to x. I want to take derivative with respect to y, correct? So I want to write, but how can I do that? How can I use these to manipulate that? This is where it's kind of today's point. This is the main thing you got to think about. What I'm going to show you is, you guys said we want d over dy, right? What's d over dy times dy over dx? D over dx. Do you see that? These cancel. D over dx. So we are actually doing, if I do these two, I'm doing this. Does that make sense?
Wait, so combining the...
No? Okay.
Hold on. If you do, sorry, which two?
Okay, so we take the derivative with respect to x to both sides, right? Okay, the derivative with respect to x, easy to do over here, because that's an x thing. This is a y thing. So I want to take derivative with respect to y. Well, how can I do that, but it be the same thing? I need these two pieces. Why do I need these two pieces? Because I can do this. Watch. I'll write it like this. Like that. They're all multiplied. And what I'm trying to show you is that these two together make this. Because the dy's cancel.
Why do you have those two?
We have those two because we want to take derivative with respect to y because it's not an x. That's the problem. I can't take a derivative of y with respect to x when it's a y.
So then you would multiply it by...
So essentially, I would change it to a derivative with respect to y because that's what I want. In order to do that to balance, I need to do dy over dx. What does dy over dx stand for? F prime. Okay? That's okay. That's what we're doing today. Yeah, that's the main point of today. What's that? Okay, but we're doing with x and y's on the same side today. This right here is old stuff, and I'm doing this to help you understand why we're doing this, but we're going to be doing this all day. D over dy and dy dx. That's the actual derivative of the function. So dy over dx is f prime. D over dx is derivative of just your x's. Exactly. Okay, so this is where I'm going with this. So just stay with me again. This is basics, guys. Okay, so we're good with this, right? Simple. 3x squared. Everybody's cool with that. What's the derivative of y? 1, right? So this essentially goes away. So I just have dy dx. What's dy dx equal? That's what we've been doing the whole time. That's what you guys have been doing all the time. We've been assuming that step because we didn't have to do that on the left because it's just a y. Okay, so let me say it one more time. What happened here was, and we're going to do this one, it's going to make more sense because it's on the same side. I'm trying to get you the basics from what we've been doing so it makes even more sense. Hopefully it's not hurting you. Okay, d over dx to both sides. We're taking the derivative with respect to x to both sides. This does not help me with the y, so then I go ahead and I make it d over dy, dy over x, because this together actually equals that, because these would cancel. Okay, so we're kind of manipulating things to help us. Okay, d over dy of y is just 1, and I have dy over dx, which we recognize as y prime or f prime, which just means the derivative of the function. So this is what we've been getting all our last problems of taking the derivative. Yeah. That's when it gets applied, and it'll be more of like just time or just that kind of stuff, but yes, you may be isolating stuff. Okay, so let me erase this. So stay with me. Don't pull your hair out yet. Okay, so now let's do the one here for the example. Okay, so I have x squared plus y squared equals 25. And it wants me to find dy dx. And the reason they put that is because we're solving for dy dx, which to us means y prime or f prime of x, which is telling me to find the derivative of this function. It's telling me to find the derivative of this function. Okay? So we need that step that I was showing you, the d over dy, dy over dx, to get that dy dx, because we're solving for it. Okay, so watch. I'm going to d over dx everything, again, just like last time. You're not going to have to do this every time. I'm doing it for the beginning. Okay?
Why are we doing x?
We're taking, because we're going to start, we're taking the derivative of x. Okay? And because it's going to, why are we doing x first? Good point.
Does it not matter?
Yeah, it doesn't. I guess technically it doesn't matter, but the reason we're doing it is because we're looking for y prime, like f of x prime, which is a y. Yeah. So we want to do x.
And then we'll find it.
In the while come, yes. Okay? Good question. Okay. So now watch. This is where let's do the easy stuff. What's the derivative with respect to x of x squared? 2x. Okay, so that part's done. No more mess. Okay? What's the derivative of 25 with respect to x?
0.
That's gone. No more mess. Okay? Now, here's the part where it's a y, but we want it to be, it's a d of dx, but we want it to be a d of dy. So I'm going to write like that. It's y squared, sorry. Okay, so maybe this will help. What we're doing is we're subbing this in for this, so we can take the derivative with respect to y. That's all we're doing, really. We're substituting that in so we can take the derivative with respect to y. To that term, because since we're going with derivative with respect to x, everything else is fine. And we are taking the derivative with respect to x because it wants me to find dy over dx, so we're doing y with respect to x. That's what that dy over dx actually means. And then also, another reason why is because, because that's y prime. If it was dx over dy, then we'd be doing the other way. We want to do y first. Does that answer your question or no? Okay. Yeah? Say it one more time. If you're doing the x first, doing y first. Okay, so if this was flipped, okay. Yeah, then it'd just be flipped, and then we'd be finding dx over dy, because that's what they'd be asking. Okay? Yeah.
What we substituted in is the same as d over dx.
Exactly. Right. This right here these are equal. That's why we can do it. It's not a magic trick, right? Because these cancel, and d over dx is prevalent. Okay? So now watch. What is the derivative with respect to y? 2y. 2x plus 2y dy dx stays equals 0. Now here's what we're doing. This is today. We want this by itself. We're solving for dy dx. That's what it's asking us for. We like that. We want that. We're looking for that. Okay? They don't cancel each other because we use to take that derivative. That's why we wanted it. Yeah? Anything else?
No, we just have to isolate that.
Now we're just solving. Just treat this like a variable there. This is a variable to us now. We're just solving like it's an x. Okay? So here we go. Minus 2x. So I get 2y dy dx equals negative 2x. And then how would I get that 2y off? Say that? Yeah, we're just doing algebra now, exactly. We divide it off. Now look, we have the answer. That is the derivative. Negative 2x over 2y. What's that? The 2's would cancel. Yes, we can even go further. Good, you're ahead of me. dy, dx, like Garvey said, the 2's cancel, so it's actually negative x over y. Does it not matter the variables are flipped? You mean with respect to this? No, does not matter. That's just how it's solved. All that matters, Morgan, is we have dy dx by itself, and that's what the problem asked me to do. Okay? What does dy dx stand for? The derivative. So negative x over y is the derivative of this function. That's what that means. Yes?
d over dy equals d over dx times dy over dx.
Yes, it'd be the same thing, yep. So if you had d over dy, the substitute for that, if we were doing, like you guys said, if we're doing y's, would be d over dx, dx over dy. Because the x's would cancel, right?
Could they ask for the derivative?
Yeah, they could, but I think for this section we're staying with the x's. But like I said, as we get further, we're going to look at time. We're going to look at growth of space. We're going to look at particle movements, different things like that. Okay? All right, so that's part A. We just did part A, so we found dy dx. Now we have to do our same stuff we've been doing. It says at the point negative 4, 3. So I have an x and a y. Well, I have an x and a y. Okay, so all I do for part B here, our f prime of x, or our derivative, is negative x over y. The point they give me was negative 4 over 3. Okay, so what that does is I plug these in. A negative negative is a positive. 4/3. What does that stand for? Your m. That's your slope of the tangent line through that point. Say that one more time. When x and y are on the same side. When you have your x and y's in a function together, implicit helps you do it faster. If you want to. But like with that one, that's not going to be very fun because you're going to have to do 2. That's why they're talking about in the beginning. If you do that, you're going to get, when you solve, you're going to get plus or minus 25 minus x squared. So you have to do both of these to figure out which one is the one you want. And so just doing implicit just is more beneficial. Okay? I'm not going to say you can't. I just wouldn't suggest it, I guess. Okay? So now we're just back to our regular game. It wants the equation. So we know that we have y equals 4/3 x plus b. We still use the same point. So we're going 3 in for y. Regular 4/3, not negative. 4/3 times negative 4 plus b. I'm just solving for b now to finish up my equation. This is stuff from Unit 1 for you. Okay, 3 equals negative 16 thirds. 3 equals 9 thirds. I'm doing that to get a common denominator. Add 16 thirds. I get b is 25 over 3. That's the equation of line tangent through the point they gave us.
When I use that substitution, like that equation,
Uh-huh.
I keep getting enough answers when like in the review passage from using the stuff before
Yeah.
the final slope and whatnot. Use like the other equation.
Okay, I can look at it. Oh, that's the find slope. That's if we're trying to find slope, but we just did the derivative to get the slope. So we're given the slope. So now we're at kind of almost, we're home free. Yep.
Is there any link between the 25 equation and then the 25 and then the 25?
Good question. I think so, because we're going up 4 over 3. So 25, an equation of a circle is x squared plus y squared equals r squared, which stands for the radius. Okay, that's an equation of a circle. It's a little bit off topic. But what's the square root of 25? 5. So that means the radius of our circle in that picture is 5. So there might be a connection to being going up 4 over 3 with a 25 over 3, just because it's over 3 as well. So I can't say for sure, but there could be. Emily, there could be. Okay, anything else? Okay, so we have seen that the problem example 1 can be solved either by implicit first, by solving for y, or doing the other way. It's more convenient, like I said, it's more convenient to do implicit differentiation if we have them on the same side. And there is some, I think the next one actually, I don't think you have a choice. Let's see here. Yeah, so like this next one, Dar, you wouldn't be able to do. You wouldn't be able to solve for y here. So this one is one that you definitely want to use it. Okay? All right, so it's not as hard as it looks. Okay? That's the thing. The implicit differentiation is a tool that just makes life a lot easier. I think it's gonna help you more than hurt you. Okay, so let's go through it. 2x to the 5th plus x4y plus y5 equals 36. Let's see if you guys pick up what we have to do new on this one. Okay, so I'm taking derivative of everything with respect to x. Okay, let's do the easy stuff first. The stuff just x's or just with numbers. Okay, so what's this one? 10x to 4. Okay, 10x to 4. That one's done. We'll skip this one because it has a y. We'll skip this one because it has a y. And then the equals is now going to be 0. Okay, the second piece here. What do I have to do? Kind of, but why? What's creating that? Are there two variables multiplying? So then what do we use? What rule? Product rule. You got to do the product rule. Okay, now this is where things are going to be, again, organization is key. Okay, so watch. Plus, I'm going to do first, derivative of the second. When I take derivative of y, what do I want to do? What we've been doing, d over dy. Whenever you take, this is kind of an easier rule to follow. Whenever you take the derivative of y, that's when the dy dx will come out. So whenever you get to the point where you take a derivative of y, a dy dx will come out. So watch. x4, I'm taking a derivative of y, so I'm getting the dy dx again, just like we did in the last one. Now the second part of your product rule, it's plus derivative of the first, okay, which is 4x cubed, and the second, which just stays y. You're getting the pattern where you're not going to have to write that d over dy, dy dx every time.
Sorry, what did you add to the end?
This is the second part of the product rule. Yep, the second half of the product rule. So I did the derivative of the x one and not the second one. Okay? Yeah, this right here, the product rule is an x times a y, so it's still two variables multiplied. Okay, so that's why on your notes I'd put product rule here so you know what we're doing. Okay, and then this guy is just a y1, so that's going to be plus d over dy of y to the fifth dy dx again. So we do have two dy dx's, but that's okay. Don't panic. We'll take care of it. Yeah, Emily? So what's that? Here? This one? Nothing, because remember this is the original. So this was derivative. This was first derivative second, or this was. You know what I'm saying? We don't take the derivative of y in this one, so we leave it. Oh, nothing. Yeah, it's okay. We had y's in our answer last time, right? So it's okay to have y's. I see what you're saying. It's okay to have y's. Okay. So now let's go and do this. And what I'm telling you is that you don't have to write this d over dy because you're going to get used to what's that mean. It just means take the derivative of the y. So just go ahead and take the derivative of it. Just know you have to have a dy dx whenever you do the derivative of the y. That's what we're going to get in the rhythm of doing. So 10x4 derivative of y is 1. So that essentially goes away. So just a dy dx on here. I still have this as it's in change. Okay, what's derivative of y5? 5y4 dy dx. Okay, so at this point, what's our goal? What do we want to do now? Isolate the dy dx's. Just remember, don't forget your goals. We're going for these. Okay, we're going for those. Who thinks they know how to do it? What do we want to do? There's two of them. What do we want to do? Emily? The two non-ones? Absolutely. You want to get the stuff with dy dx's alone by themselves. Why? Because then they have a what? A common factor. Common factor, not, but yeah, I know what you meant. So we're going to move this, and we're going to move this, because they do not have dy dx's. Okay, so now we have this, x4 dy dx plus 5y4 dy dx equals the two things we moved over. They're both negative now. All right, questions yet? All right, so like Emily said, now that these are together, they both have this in common. We're going to pull it out. So now we're going to do this. It'd be dy dx. This is where your algebra skills come into play. Like that. That's all you did. Just took it out. Why do we take it out? Because what's that do for us? Yeah, it isolates it. Now how do we get rid of this little chunk here? We just divide it, exactly. So we'll just divide this guy under here now. And I'll do that on the next page. So get that written down. I'll do that here in a second. Just let me know when you're ready. Good to go? Okay, so then it's going to be, I need to get my notes here. So that means that the last step would be dy over dx equals negative 10x4 minus 4x cubed y all over x4 plus 5y4. So that is your derivative. This is the derivative. That's okay. It has x and y's in it. No big deal. So on that problem, the second part of that problem, it says to find the slope of the tangent line at 1, 2. So this time it just wants the slope, not the equation, so we just plug in 1 and 2. That's all we do. We put 1 in for x. So we're doing part B, the tangent slope. So we plug that in for x, that in for y. So that's going to give us negative 10 times 1 to the 4th minus 4 times 1 to the 3rd times 2 all over 1 to the 4th plus 5 times 2 to the 4th. Okay. 2. Okay. So the top, when you work that out in your calculator, do your calculations, you're going to get negative 18. The bottom is going to be 81. This reduces to 2/9. So negative 2/9 is the slope for that tangent line. That's all it wanted. Didn't want the equation, so we stopped there. Okay. Like I said, it's not insanely hard. It's all about organization. It's all about organization. So we're going to do one more example for this lesson, then we're going to go back and I'm going to do the example from yesterday that we skipped. Okay? Any questions? All right. Okay. So I'm going to pause this one. I want you to try it. See what you can do. Just see what you can do and see where you get stuck, and let's talk about where you get stuck. So go ahead and try it real quick.
multipliers at the end?